Okay, our next presenter is Nuri Jeong from the Neuroscience PhD program. And Nuri's presentation is Never Miss Your Favorite Taco Spot Again. So are we ready with the timer? Are we ready? Are our judges ready? And are we ready online? So the timer will start when you begin.
What brought you here today? What goals are you trying to accomplish? And how will you reward yourself once you accomplish your goals? How about tacos? Maybe you already have a favorite taco spot here in Atlanta, but how will you find another one in a new city? What if I told you that I found the brain mechanism that helps you do exactly that? Decades of research tell us that the brain region called hippocampus drives rapid learning of a new environment. When you move to a new city, brain cells in the hippocampus are actively storing information about different places that you want to remember. Say the restaurant with awesome tacos. But for some, this is not so simple. For example, Alzheimer's disease impairs the ability to learn a new environment or even navigate in a familiar environment. How come? Studies that have looked at these patients' brain tissues found that there's a large loss of a type of brain cell called interneurons. But even after decades of research, we don't know exactly how interneurons help us learn new information as important as an awesome taco spot. So this is where my research comes in. I wanted to understand how interneurons change their activity when learning goal locations in new environments, specifically the locations they want to remember how to get back to. To do this, I designed an experiment placing mice in a virtual maze. I recorded the electrical activity of over 1,000 neurons in mice learning where in the environment they can get a reward. I wanted to see if I could manipulate interneuron activity in mice learning to either boost or impair their learning. So I also stimulated the interneurons in mice performing this task in both familiar and new environments. And what I found was striking. When I stimulated interneurons in mice learning in a new environment, the mice never learned where the goal locations are. If I stimulated interneurons in an environment they already knew, it did not impair their ability to remember the familiar goal locations. Now, these findings tell us two things. One, normal interneuron activity is necessary for learning new goals. Two, interneuron activity is not necessary for recalling old memories. I'm really excited about this result because this is one of the first direct pieces of evidence that interneurons are actively involved in storing new information crucial for goal-oriented behavior. This is only the beginning of our understanding, but next time you have to remember your favorite taco spot, you got the interneurons got the job.